Hello everyone, welcome to this session number 306, I think, afternoon. Well, I will continue with this exercise that I tried a few hours ago, and well, basically currently we have this, and this failed with this. With this it's okay because it's empty, but with this fail. Now, yeah, the idea, I still with the same idea, is create a new reference, yeah, for this node, for every node and every node in general. Every node contains the value and contain the neighbors. This is the idea. Now I will receive this error. I would like to check what is the nodes that we have here, because for example when we start one moment please, I think that is raining here. Sorry, I'll be back. Okay, now again we have this node. Yeah, basically this node is this, and see, it's create the scene, the map, the new nodes. Okay, the new node is initialized with, yeah, we are saying that this new node, it's equal at this new node. And this is the value. Oh, maybe it's for this, because you see that, for example, you receive this node. Yeah, this is the first node. Yeah, and create whatever with this data structure, and here I am saying, hey, node, this is the new node, that is one. No, in this case it's not one. Could we have, oh yeah, it's one. One and new node, but what happened with the neighbors? Maybe it's for this, because in any moment we are set the neighbors. Even here, for example, we don't set the neighbors in the new nodes. Yeah, I think that is for this, because it's necessary. We are mapping the nodes, but we are not setting the real neighbors to the node. Yeah, for example, here is necessary what is where are the neighbors of this value. Okay, okay, here receive the first node in the index. I think that this is not necessary, because the node contains the value. Here, for example, the node contain the val. In this case, could be node val. the map contains, here is node.val, node.val. Yeah, okay, here receive the node 1, for example. 1 is different to null, it's not contained because it's the first time that is the first iteration. Okay, is add. Now map contains the one nosor. Okay, create this new register in the map. And next to is node. Okay, what is the neighbors? The neighbors is 2 and 4. New nodes contains the 2. No, okay, create and set. Okay, and then the final is only okay, here in scene should be appear the elements. Yeah, we can for each the for let me check. For each set Java JavaScript Java hash set it's only here, it's integer and double point and scene, and here we can say that new nodes new nodes dot get n dot no the map contains a new map dot put map dot this contains the okay, maybe here I will here it's I forget always how iterate over the hash map. It's with the entry this. Yeah, it's with entry set. Yeah, this is an integer and this is a list of nodes. Node entry, and here is map, and here we can say nodes in the entry dot get key dot put and entry dot get values. Yeah, because for example we are mapping the 1 and this is the neighbors, the 2 and this is the neighbors, the 3 and this is the neighbors, and but in any moment we are related or we are setting the neighbors. New nodes entry index, where appear index? What? Here is node dot val and obviously here receive only the DFS. Okay. Get is get value. Get key and get value. Mm. Is get key. Get key. Get value. Get key. Is not put. Is add. New nodes. To put this. No, it's not new nodes. Is yeah. It's new nodes dot neighbors because it's the object. Yeah, is this. It's equal to entry. Now let me check another examples. 2 4 1 3 2 4 1 no, it's the same. Come on, any test? No. Okay, I hope that oh, nice. Okay, let me share my solution here and okay, this is my first option to resolve. Let me delete this and okay, looks better. DFS. Set neighbors and this. Let me clean. This basically is the same. Or sin add is in the case that is not contained is add next to is for each the DFS solution using DFS. Okay, let me it's a very I don't like this question. It's so confusing, more for the reference, but okay. Now let me check if I can improve. Okay. Oh, this is my solution. Is this in here? Okay. Now I think that we can avoid new nodes or the map. I think that we can join. Yeah, but I'm not sure. Okay, here. let me check if I can join the new nodes with the map. The map help us to new node it's equal new node it's equal that. What happens if I remove map? I have this is this or this return scene is at node.val. Here I think that we can use the same map for ask scene has been processed before ignore, but well, yeah. Let me check new nodes. Okay, I think that we can remove the map, the first map, because here is receive this new nodes, and basically we are saying new nodes. Okay, we have this new node. Return, for example, in this case, return the 2 and 4 are the neighbors of 1. In this case, new nodes contains the 2, no, okay, please add without this, and yeah, the map map, yeah, here I think that we can remove new nodes because okay, yeah, sure, let me remove the first map, this, and means that when I receive this, the node it's equal, okay, yeah, here the first the map is contained here is new node contains, oh sorry, new nodes contains, new node is another map, new nodes doesn't contain the node.val. In this case, new nodes it's this, okay, new nodes new nodes contains no mat.put, it's new nodes is this, oh yeah, new nodes contains this, no new nodes dot put and the new node, okay, this new node dot val in node, in this case node dot neighbors, yeah, new nodes, I can remove this, yeah, because here I think that we can convert this DFS in a function that return the node for use here, and basically is okay, iterate over the neighbors, and basically is transform it and set or add, yeah, because with our current solution, what is, let me check well, it's not too bad, but I think that we can improve with this. And with the memory, the memory is it's a little bad. Okay, let me check here. Okay, this return a node, and the first if is null or has been visited before, stop it and return no. Yeah, in this case we can check, okay, this node is has been visited before. Okay, now new nodes contains no, in this case it's not new nodes, because if we are new nodes contains not bad. In this case, I think that it's not necessary save anything in a hash map, because when you, for example, have when you have this adjacent list, I can copy paste here. Okay. Yeah, basically with this, we are here. Yeah, in the first. And the first is basically take these neighbors 2 and 4 and ask if 2 is not in scene. We are sure that we can say that new node, no, new no, no, yeah, it's necessary the map, I think, because okay, we are in the node 1, yeah, and we create this node. Okay, and we can say, okay, the node have this value, but is the neighbors are empty. And here is basically node, or in this case 1 dot add, because it's a list here with the neighbors dot add, and this dfs and the value, yeah, and this go again to the with this node, because this is a node, and apply the same. In this case 1 2 is here, this have the 1 and the 3, and we start here, and this has been visited before. Yeah, no, it's necessary save these values, because for example this has been created before, basically is this, but we don't have the reference. Yeah, we need save maybe in a list or in a map. In the map with the value 1 is this object, 2 is this object, 3 is this object, 4 in this object. Yeah, okay. Now, okay, we only need a new nodes. Well, I think that it's very similar, but the only difference is that we can return new nodes. Oh. Okay, here. This is not necessary because we should oh, and this is the similar too. this return a node, and we can say node it's equal null or is contained return. Here is new node dot get node dot val. All the time return the new node, and here is the same. Here. Okay, now it's scene dot add node dot val. Okay. Even this is not necessary because we can check the map. Replace this for map.put and node.val and new node with the value less 1, yeah, and remove this scene. Yeah, with this we are sure that we can use the map with to propose. The first is validate which node has been created before and the mapping. Okay, new node and empty list, whatever. Now new nodes contains the key of node.val. New nodes. New nodes. Sorry. This is new nodes and this is new nodes. New nodes contains this. And scene is new nodes contains key. This or this return the value. Okay, in this case is not contained. Yeah, if cross this line basically is because it's a new. Yeah, node.pull. Okay, new nodes it's equal new node puts. Here is wrong. It's not contained. Put the value as a new node and the new node with the value and the neighbors. But for the neighbors, okay, we should replace every neighbor of this value. New nodes.put node.val, new node, val, and the neighbors. And we should, for each these neighbors, you know what? Let me change this for new array list. Yeah, an empty, and here for each the neighbors node and node dot and neighbors it's neighbors, and here we can say that yeah, new nodes dot get node dot val because is the root, and here is add, and here is dfs and n. Because on the final T should return the new node, and here return new node. Well, I think that basically is this. Because for example the first time receive this, let me copy this here. This is the remove. The first time receive we have this the 2 and 4, yeah, and we can use the DFS function to send this object, and the object have 1 and the neighbors have 2 and 4. Okay, new nodes contains the 1 dot, well, node dot val that it's equal 1, no, and it's different to null, it's not execute. New node dot put the new node and sorry, the number that is 1 and the new node that is 1 and an array list empty. And next to we need for each over these neighbors and new nodes dot get here new node dot get node dot val that is 1, yeah, here, and add to the this list DFS of n. In the case that exists, only return the object. In other case, create. What? New nodes? What have new nodes? Ah, here is a node. This is wrong. Why? New node. Ah, no. Here is new node dot get that it's an object neighbors, yeah, because it's the name of the list, yeah. This is neighbors dot add. It's much yeah, was better my other solution. Okay, let me check. Okay, this is my first solution. Oh, sorry. Yeah, this is my. Oh, come on. Okay, this is my first solution that is a little bit more fast. Yeah, it's much better this solution. My previous solution using more code, but it's much better. But this, okay, I think that. Oh my god. Let me publish. Solution using DFS without no, ni Java. And here is this. Here no, here is necessary this. Now yeah, like that. And recursion. Okay. Okay. Now, how many? Oh, I am very need to have 150 million problems. I have the challenge to fill up all September and get the signal. But well, let me check. Problems. mm. Investigation, binary search, backtracking. No. Successful page position. Grabs. What is the other top? 105. Six pointers in Windows. Mm-mm-mm. Linked list. Binary tree. Oh, this problem. I will try in a few days. Flatten binary tree. Binary tree. Maximum path zoom. Binary search tree creator. Okay, let me try with this. What is the rate of this? Oh my god. When it's less to 50 percentage is hard. One moment please. Okay, I'll be back. I remember that I gonna check the current the daily challenge. Oh no, I don't like this kind of question. I remember I think that it's I tried it before, no. But I remember is with a formula that calculate when is this. No, I don't have any interest to resolve. Well, this binary tree maximum path sum. A path at a binary tree is a subsequence of nodes where each pair of the adjacent node is a sequence has an edge connecting them. A node can only appear in the sequence at most one node that the path does not need to pass through the root. The path sum of paths is the sum of the nodes value in the path. Given the root, so this is better to respond to analysis, no empty path. Oh, I remember a few months ago I tried to resolve another problem. I think that delete node or something like that, and the final I didn't resolve, but discovered this way to this operation. Oh my god, I don't. Okay, let me check. My little universe is here. Oh, it's too small. Okay. Now the constraints. The numbers of node 3 are between 1 and 3 multiplied by 1. A long value, and this is negative and positive. Okay, here. Mm-mm-mm. Okay. Now here it doesn't matter the origin. Means that, for example, every parent have the sum of the previous values. For example, this the add is this, for this is 7, for this basically we have two options, is this plus this is 35 and this plus this is 27. What is the greater? The greater is this. And basically for the right we have 35 and for the left we have, okay, less 10. Here, well, here is 9. Here should be less 1. In this case is 35. Come on. 42 what? 15. But even we can this plus is, we have this, the max value here is 15, the max value here is 7, and we can add this value 15, 20, 44, and we can add here 24. No, this is wrong because we can have this. It's possible have this. The path is the sum of parallel nodes value in the path in the root. I have this though, if it's possible, because it's a no, because cross 2 times this or this. No, I have this though. If it's possible, this 15 okay, let me one. Yeah, for example here, what is the result? 6 y6. I think that is 1, 2, 3, 4. No, 1, 2, 3, 4. No, 1, 2, 3, 4, 5, 6. Yeah, we can do this operation. Okay, got it. Is good to know. Okay, now okay, we are here. No, I think that we need to go to the final. Yeah, starting for the final, that in this case is 9, is the max value. Okay, come back here to 9, and this is the left with 2. Yeah, this is the max value here. Now for the right, we can send we have this. In the right, we don't know in this moment. Okay, we need go to this and 7 plus 20 is this, 20 plus 15 is 35. We have three options, this and this and this. No, come on again. This is the 15, this is the left, here is 15, and this is the max is this value, and basically is what is the greater of this or the add of the three. Yeah, we need an max that it's 0 to calculate all the time this. For example, in this case is return the 35. Yeah. Imagine that this is 19. 19. Come back here, 19. This plus this is basically 9. Currently our greater value is 9. Okay, got it. Now here this operation, no, here is 7 is the greater here. Now 15 is here. We can apply this add. 15 plus 20 plus 7 it's equal 22. Okay, this is replaces for 22, and we should return the greater value that in this case is 35. Oh, come on. And do this, apply the operation mat.max. In this case is 35. Now greater is 42, and here 19 plus 10 plus less 10 plus 35 yeah, it's basically this path is the greater value because it's 19 less 10 is 9 plus 35 it's equal 34. No, even it's here. Mm-hmm. 9 plus, sorry, here is 44. Yeah, it's greater 44. Yeah, I think that is this. Okay, let me do again. Okay, but now how can I return this value? We can start go this and apply DFS, and this come back 9 plus 0 and 0, and this, what is greater? We can do the add L plus mid plus right, L plus mid and mid plus right. Basically is, for example, this, we have three results. This is 1, no, sorry, this is 1, but that is this. The other is only this, that is this, and the last is this. Yeah, for example, here is the first is 24 when is the add of the 3, next to is 35, and here is 27. What is greater in this case is this. and we can have max it's equal 42 all the time. Try to calculate this. Okay, sorry, I was checking Twitter. And now with the DFS, the idea is forget a little bit this. The idea is return the max value to the previous. In this case, is DFS, and return the value. Yeah. Okay. Now here is integer max it's equal 0. No, here integer dot mean value yeah, and this here. Let me check only the description. At least one. Yeah, okay. Can't be null. Okay, now here is root DFS and here receive the root, and this should be return a number that in this case is mat.max between this and max. Yeah, and here is max it's equal this, and yeah, even we can only return this. Yeah, and now it's necessary to create here the private integer or int DFS and to receive a 3 node if node it's equal null, return 0. Yeah, when it's yeah. Then next to is integer L it's equal DFS node dot left. In the case that is null, return 0. This is right, okay. And here we need to apply this operation that max it's equal mat.max between L plus node dot val plus right, and here is L and this, and the other is basically this, and here is return max. L mat.max. Yeah, max. $26 what? Why? Okay, let me check the example. This start with the root that is less than. is 10, it's null, no. The left, go to the left, go down here. Now it's 9, it's different, it's equal null, no. Go to the left is null, okay, return 0 for L. The right return 0, and max is the mean value. Here is mat.max between 0, that is L, plus 9 plus 0, that is 0 plus 9 plus 0 is 9, and is max to this value. Okay, right now the max is 9. Yeah, next to is left to 9. Well, it's the same here because it's a leaf, and basically the right and the left both are 0. Yeah, the max is 9. Okay, return the 9 here. The max value here is wrong, because we should return the value between the left and the right, because we can return the sum of these 3 elements here. It's only the 2, not the 3. Yeah, let me explain here. Here is the max. Yeah, this is basically plus of this, or not dot val plus air. No both, no the 3 case, only 2 case. Yeah, okay, now okay, I don't want celebrate because it's a hard problem. I don't think that resolved at the first time. Oh my gosh, I think that it's a good signal. Oh my gosh. I hope that don't receive an error, because I will cry. Okay, yeah. It's so okay, 91 to 96. Well, at least cross or pass the most test. Here is wrong. These two, and what is the test? This is test. Why less 2 should we return less 1? And I no, expected 2. What? The first. Okay, node it's equal null. What is Twitch? Yeah. Receive 2. Return 0. DFS. Well, I think that here is not necessary this, because always I add the node. We can only use this plus node.val, and okay, works. In this case, I think that is the same. Max, it's equal this r plus node.val, and avoid this. No, it's necessary. Okay. Oh my gosh, it's only one. mm. L plus node plus right. Yeah, because for example here we receive the node that is 2. Okay, go to the left. The left it's less 1. To the left return 0. Okay, now we are here in less 1. We are 0. We have 0, sorry. The right is 0, and it's basically less 1 plus, no, less 1, sorry, 0 plus less 1. Well, in this case the max value is less 1. Now here less 1 because don't have any element, and basically the max value is less 1. Between less 1, no, between 0 and 0, what is greater? 0 plus 1 plus less 1 is less 1. Okay, now here this number 2 in the left have less 1. Yeah, here is less 1. And now go to the right, and in this case the max value is less 2. Okay, now well, I think that having between max and node.val, only that. No. Daily check. Oh my gosh. It's a new day for. Okay. Oh my god. 15. No. Okay, I think that this is a temporal fix, but it's not the idea. How can I think that you should for example, if t return, let me read this. If we are trying to avoid the negative numbers, okay, let me check what happened if, oh, I can, okay, here, less 1, less 1, and less 1, oh no, this 3. Should be output 1 always. The results are positive. For example, here when the result is negative, ignore and only have mat.max between 0 and dfs to the left. This help us to ignore the negative numbers because transform it to 0 basically. Here is right, and here is right, and here okay, but now let me check if this is 0. I'm not sure about this because math.max, the L math.max L, only the left, the right. Yeah, I think that. Oh, we resolve it. Nice. To be honest, I didn't expect resolve, but we can do it. Let me share here. I don't feel as a hard problem. I'm not sure about this. L, right. I think that it's enough with this. No. Math. No, this. Yeah, because basically these cases are the same that this. Okay, let me. Yeah, even much better. Okay, nice. Here solution, simple solution using recursion in English, recursion, using recursion, Java. I don't feel as a hard problem, but let me check the editorial. Post order. Yeah, this is the key. I think that ignore the negative numbers. Yeah, basically it's the same. And here we can only return max. But well, it's okay. Yeah, me too. Yeah, but I think that it's because before I remember that I tried to do another problem and discovered this, but well. And okay, we are one. Yeah, see you for watch this transmission.